It seems no matter where I go, what book I look at, what old exam I look at, what internet source for questions I look at, they all seem to have playing card questions. So look at a standard deck of cards. 52 cards in a deck, if you didn't know that. Of these 52 cards, 13 are hearts. Okay? That's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. That's 13 cards. 13 of them are also diamonds. Same kind of arrangement. But you also have 13 spades and 13 clubs. And I purposely put them in these colors because hearts and diamonds are considered to be red cards. Spades and clubs are considered to be black cards. Aha, so this makes this really, really interesting in looking at all the possible arrangements that you may have here. Okay, so now let's start answering some of these questions. Ready? Let's go. How many different 5-card poker hands are possible? Think about this. You have 52 cards, right? Do you care if they're hearts, diamonds, spades, or clubs? No, you just want 5 cards. So you're going to choose 5 cards. How many different arrangements can you have of this? Okay, well, let's go. Boom. 52. I'm going to choose 5. Boom. Ba-dum. Oh my goodness. This is one of the reasons why card games are very, very much a card game of chance, because you have 2,598,960 possible combinations of the 52 cards. Holy man, that seems like an awful lot. Well, in fact, it is. Okay, that's huge. That's massive. So let's start throwing some restrictions down. Okay, so first restriction is, what if you want just all diamonds? How many different arrangements of just diamonds are there? Okay, you're not looking at the probabilities here. That's a completely different section of the course. What are your chances of getting 4 diamonds or 5 diamonds? That's a different type of probability we're going to look at. Not in this course, but actually if you take Math 30-2, they talk about probabilities, which is very, very interesting as well. Okay, let's just stick to this. How many different arrangements can we have? That's a big thing to understand. Look how many diamonds you have. You got 13 possible diamonds here, written right there, 13 possible diamonds. Out of that, you're going to choose 5 cards. It's that simple. Okay, so let's go. 13, I'm going to choose 5. Look at that. I have 1,287 arrangements, 1,287 arrangements of diamonds that I can get. Okay, so now let's start getting a little bit stickier here. I want exactly 3 kings and 2 queens. So in other words, I've got a king in the first spot, another king, then a queen, and a queen. Does the order matter? No. As long as I have 3 kings, 2 queens, I'm good. I don't care what order they're in. I really don't. Okay? I can have a king, 2 queens, and 2 queens and 2 kings, that's fine. Or 2 kings, 2 queens, and a king, or mix them up whatever way you want. But as long as you have 3 kings and 2 queens, you're good. That's why this is a combination, not a permutation. Okay? So you got 4 possible kings, 1 from the hearts, 1 from the diamond, 1 from the spade, 1 from the club. You're going to choose 3 of those cards. And, which means multiply, you got 4 possible queens. And you're going to choose 2 of them. Oh, okay. 4 choose 3, 4 choose 2. Let's do it. 4 choose 3. And, so we got to multiply this. 4 choose 2. For a total of 5 cards. Let's see. I only have 24 possible arrangements of this. 24 possible arrangements. That's 24 out of that one that was way up here. Holy smokes, that's huge. What was that number again? I'm kind of curious. That number was 2,588,000, 2,598,960. 2,598,560. So you only have 24 chances out of that total of getting this. That's what makes this so difficult. Okay, let's even make it even worse. 4 aces. So think about it. I still have 5 cards, but I want exactly 4 aces. So in other words, I only have an ace from a heart, from a diamond, a spade, and a club. 4 aces. I'm going to choose all 4 of them. What do I got left? That one card can be anything you want it to be. So think about it. If I have 52 cards in total, 4 of those cards are aces. That means I got 48 cards left. Out of that 48 cards, I'm going to just choose 1. Okay? I'm going to multiply this out now. Let's go. Let's see what it looks like. I'm just going to mouse up to here, and I'm going to grab this because this is already arranged for me. That's great. I'm going to move that over. Go on, you. There it is. And I'm going to go to 4, choose 4. There's my choose 4 times. I want now 48. Choose 1 more card. There it is. Enter. I got exactly 48. I got 48 arrangements of aces. And specifically, think about that. There's only one choice for that. Exactly 4 aces, I mean, I have one choice. That's it. The other thing that gets me here is I got 48 more choices that I can choose from. That's where the 48 comes from. Interesting. Let's look at the 4th one. Exactly 3 7ths. Well, think about this. Doesn't that look an awful lot like this one again? Yeah, exactly. Exactly 3 7ths means I've got 4 7s to choose from. A heart, a diamond, a spade, or a club. I'm going to choose, out of those 4, I'm going to choose 3 of them. Okay? And what makes up the other 2 cards? Well, think about it. 7, 7, 7, and 7. That's 4 cards. From the 52 leaves me with 48 cards left. And I'm going to choose only 2 of them. Wow, that's interesting. That should give you a nice number now, shouldn't it? Okay, 4, choose 3. Here we go. I'm just going to move mouse up to there because that's going to help us out a lot. I'm going to go 4, choose 3. So just mouse over to choose 3. There it is. Took me a while. And look at that. I got 48. And I'm going to choose, oops, I'm going to choose 2. Boom. See how that, using that button again, that's just that history button in your calculator, kind of saves you a bit of time. 4,512. 4,512. Okay, now let's get even more complicated here. 5 cards of the same suit. Okay, 5 cards of the same suit. Now think about it. Okay, that means I've got 13 diamonds, 13 hearts, 13 spades, 13 clubs. So I'm going to choose 13, and all 5 of them are going to be chosen. But I can choose, like I said, either hearts, diamonds, spades, or clubs. So I got 4 choices for that, right? That's what that works out to be. I'm going to let you figure out the rest of this in your calculator. Once we figure it out, it really is not necessary for me to go out and throw this in your calculator and get the numbers. Okay, now let's look at part 6 here. I want at least 3 queens. So think about it. I can have 3 queens, or I can have 4 queens, but can I have 5 queens? No such thing, right? There's only 4 queens in the deck. So think about this. So what do I got? First one I've got is I've got 4 queens. So think about it. I can have 4 queens. That would mean I'd have 1 regular card. Okay? Or I can have 3 queens and 2 regular cards, right? Because I want at least 3. I'm not going to go 2 queens and 3 regular cards because that's not part of the question. I can either have 3 queens or 4 queens. So here we go. Let's figure out how this works. All right. So there it is. I'm going to have, how many queens do I have? Total in the deck is 4. Okay? I'm going to choose 4 of them, which means that now I have 48 cards left, right? 52 minus the 4 queens is 48. And out of those 48, I'm going to just choose 1 card. Okay? Or I can have, and or means plus, out of the 4 queens, I can choose 3. That would mean that I have 2 regular cards left. Okay, so out of the 48, I would choose 2 and add them up. Or sorry, multiply them up because that's an and, right? Okay. Wow, is that ever neat? Well, almost done, folks. We got 2 more questions to look at. This one says, think about it. This one says at most 2 kings. Well, think about it. I can have 0 kings and 5 regular cards. Or I can have, think about it, 1 king and 4 regular cards. Or I can have 2 kings and 3 regular cards. Bum, bum, bum. They're all adding. Okay? So think about this. Out of the 4 kings, I can choose nothing. I can choose nothing. So let's make sure that that's a C here because you won't find a K on the calculator. Okay? And 5 regular cards. Well, of course, this would be times. Well, you only have 48 cards left, right? Because you want no kings. Take the 4 kings out. You're left with 48 cards. Choose 5. Plus, now you want 1 king. Okay. So out of the 4 kings, you're going to choose 1. That leaves you with, again, 48 cards that are not kings. You're going to choose 3. Or sorry, choose 4. Oops. Okay? And lastly, you're going to have 4 kings. You're going to choose 2. And out of the 48 cards remaining, you're going to choose 3. Boom. There's your wonderful arrangement for number 7. Okay. Whoa. Look at this one. This one's the beast. This one's going to be very interesting to do. Now, there's 2 ways of doing this one. Read it. It says you want at least 1 red card. Oh my goodness. Okay, at least 1 red card. So what does this mean? You can have a red card, 1 red, right? 4, you'd have to have 4 black cards. Or you can have 2 red, right? And 3 black cards. Or you can have 3 red and 2 black cards. Or, and of course now, you can have 4 red cards. Oh my goodness. And only 1 black card. Or your last, oh my goodness, 5 red, 0 black cards. Oh my goodness. Oh, this is just a pain in the butt. Think about this. Remember, if you're going to split the deck in half between red and black cards, you have 26 of each. So if you think of the first one here, you're going to have 26 red cards to choose from, but you're only going to have 1 chosen. You're going to have 26 black cards, and you're going to have, black cards, and you're going to choose 4 of them. You're going to add this now to this combination here. You have 26 red cards again, okay? You're going to choose 2. You're going to have 26 black cards. You're going to choose 3. Then you're going to add this to the next one, which is 26 cards, red cards. You're going to choose. Look how this becomes just, oh my God, yeah, this is painful almost. 26 black cards, you're going to choose 2. And then you're going to add it to this one, which is 26 red cards, you're going to choose 4. You're going to have 26 black cards, you're going to choose 1. Oh my goodness gracious. And then finally, you're going to have 26 red cards. Oh, you're going to choose all 5. And of course, if you want to put that in there just for the sake of putting in there, you're going to have 26 black cards. You're going to choose none at all. Then you're going to figure out each and every one of these. And when you figure out all of these numbers out, this one on your calculator and this and this and this and this, it's all going to add up to, get this, 2533180. Holy moly, 2,533,180 possible ways of doing this. Is there an easier way? Yes. Yes, there is an easier way, and it's called the complement. It's called a complement. What does this mean? Well, think about this for a second. Let's look at all possibilities of this. If you look at all the possibilities, which is 52, choose 5. That's red cards, black cards, all of them mixed up. Okay? That's your big possibility. This is all possibilities. Okay? Now, think about this. Wouldn't it be interesting to say, I wonder how many possibilities there are of just black cards? All black. Well, think about this. Isn't there 26 black cards in total? You can choose all 5. Huh. Now, remember, this is all possibilities, which means you can have 5 black cards, 5 red cards. You can have any kind of mixture in between. But if this is all the black cards and we subtracted them out, that's why this is called the complement. If you subtract that out, does that mean all we have left is 5 red cards, all of them red? And if you do those numbers, guess what you end up with? That's called the complement. And what you're doing is you're eliminating all of the black cards and you're only left with red cards. Wow, I kind of think the complement really helps us out here now, doesn't it?